I am here to talk about OpenMRF, which is an open source framework for magnetic resonance fingerprinting. And basically, the big idea behind this project is that MR fingerprinting is a pretty cool technique that has gained a lot of traction over the past few years for fast multiparametric imaging, so quantitative MRI. But I can tell you from my own experience that it's actually not all that easy to get it started from scratch if you're not in a group that does a lot of MRF. So what we try to do is kind of tackle that problem and make it a lot more accessible and easy to get started, and also hopefully to help standardization and reproducibility in this field, especially in quantitative MRI, where it's really important. So this framework includes flexible sequence creation based on the Pulseq standard. We also implemented a automated metadata storage. So for every Pulseq sequence that you create in this framework, all the relevant metadata is automatically backed up and uniquely identifiable with an MD5 hash. So later when you acquire data, the framework automatically extracts the correct metadata from your backup without any additional user input required. The framework includes a pipeline for digital phantom simulation. So if you create a sequence and want to make sure that it actually does what you intend to do, you can double check that in the digital simulation. Another feature is automated trajectory calibration, which can be especially important for all these advanced non-Cartesian readouts that happen in MRF. And one of the obviously essential things to MR fingerprinting, if you're familiar with it at all, is the dictionary creation that is necessary for parameter estimation. And to make sure that you're actually accurately reflecting all the things that your sequence does in this dictionary, the dictionary is created directly from the seq file that is created by Pulseq to make sure that all the timings line up. Yeah, sorry, did we have a question? Yes?
Yeah, I'm sorry that I think we're only seeing the first slide.
Yeah, I'm clicking through. So do you see the? I hope there should be things kind of coming in. Do you see those coming in?
We just see it like an OpenMRF from Griesler University of Michigan below.
Oh, and you don't see the additional. I'm so sorry about that. Let me try. Okay. That is too. Oh yeah. Okay. I see now. I'm so sorry about that. This is where I was. This is the dictionary creation. That is what I wanted to show you. I'm sorry about that. So basically, this is anyways the most important point of this all. This whole project has been validated in a multi-site study at 3 different sites in Europe and North America, and on 3 different field strengths. And we also tested the in vivo readiness of the project by scanning a liver, heart, and brain of volunteers at these 3 different field strengths included so far. The cardiac acquisition especially highlights that we're also able to incorporate an ECG-gated acquisition scheme in this framework. And the whole project includes a bunch of additional features like field mapping or single parameter reference acquisitions. So basically everything you would need to get started with quantitative imaging using magnetic resonance fingerprinting is included in this one framework. And if you're interested in playing around with it, the code is openly available within the Harmonized MRI project. And we also set up a documentation website that has more information. Or please come to my poster and talk to me about the project. Looking forward to that. And sorry again about the slide confusion in my slides here. Thank you.